So, on the morning of November 26th, a series of quakes really shook things up in Northern California. In this explainer, we're going to break down what happened, what it all means for such a seismically active state, and, most importantly, what you should do when the ground actually starts to move.
The very first question the US Geological Survey asks after a tremor is a really simple one. Did you feel it? Whether you did or didn't, that shaking near Gilroy is actually the perfect opportunity for us to understand the forces at play and, get ourselves prepared.
So here's the main event. Early one Wednesday morning, it wasn't just a single quake. Nope, it was a whole cluster of them that rattled the area southeast of San Jose. Now, this wasn't the big one by any stretch, but it was definitely enough to make everybody pay attention.
Okay, so let's get into the play-by-play. What exactly went down on that Wednesday morning?
It all happened so fast, in less than 10 minutes, really. The first one, a 4.0 magnitude, hit around 6:15 a.m. Just a couple of minutes later, a smaller 2.7 followed it up. And then, boom, right after that, another one, a 3.9. This kind of rapid-fire succession is exactly what makes it a cluster.
Now, what made this whole thing feel especially potent was just how shallow it was. The epicenter was only 3 miles deep. And you gotta understand, when a quake is that close to the surface, the energy waves don't lose much power on their way up. That's why the shaking can feel so much sharper and more jarring, even from a moderate quake like this.
And this little cluster, it didn't just happen out of the blue. The whole region had been pretty active all week. There were 3 other quakes of magnitude 2.5 or higher pretty close by, including a 4.3 tremor that was actually the strongest of the bunch. It's just a constant, powerful reminder that the ground beneath California is always on the move.
So, we're throwing all these numbers around. 4.0, 2.7, 3.9. But what do they really mean? Let's take a second and decode the science behind all that shaking. The big word here is magnitude. It's basically a measurement of the total energy that gets released right at the earthquake's source. A lot of us grew up hearing about the Richter scale, but scientists now use something called the moment magnitude scale. Why? Well, it's just way more accurate, especially for really big earthquakes where the old scale kind of topped out. So, here's the most important part. How does that number translate to what we actually feel? Well, anything below a 2.5, you probably won't even notice. But the quakes in that Gilroy cluster, they fall smack dab in that 2.5 to 5.4 range. That's the often felt zone. It's definitely enough to rattle your shelves, but it's very rarely going to cause any real damage.
All right, now that we kind of get what happened locally, let's zoom out, way out. How does a little cluster like the one in Gilroy fit into the global seismic picture? The scale of it all is, well, it's pretty mind-boggling.
Okay, just look at this number, 500,000. That's roughly how many earthquakes are detected by instruments all over the world every single year. Most of them are so small we never even have a clue they happened.
Now, of that 500,000, about 100,000 are actually strong enough to be felt by people. That is still a huge amount of shaking going on around the planet day in and day out.
But here it is. This is the number that really puts it all into perspective. Out of all of those, only about 100 a year end up causing any damage. It just shows you there's a huge difference between an earthquake that's felt and one that's actually dangerous. And of course, with those truly damaging quakes, the shaking itself is often just the start of the problem. A really strong earthquake can trigger a whole cascade of other hazards. We're talking fires from broken gas lines, landslides, even tsunamis. And that's exactly why being prepared is so incredibly critical. Okay, so this brings us to what is, without a doubt, the most important part of this whole explainer. What do you do? Let's walk through the expert-approved plan for staying safe when an earthquake hits. Seriously, forget everything you've ever seen in the movies. The single best thing you can possibly do is drop, cover, and hold on. Drop to the ground, cover your head and your neck, and if you can, get under a sturdy table or desk, and then hold on to it, because that thing is going to move around with the shaking. But what if you're not near a table? Okay, quick fire round. If you're in a car, pull over, stop, and put on that parking brake. In bed? Just stay there, roll onto your stomach, and cover your head with a pillow. If you're outdoors, get into an open area away from buildings. And this one's crucial. If you are inside, stay inside. Running outside while the ground is shaking is one of the most dangerous things you can do. And please remember, the danger isn't necessarily over when that first tremor stops. As the officials always remind us, you have to expect aftershocks.
The first quake can weaken structures, right? So a smaller aftershock could be the thing that actually brings something down. You always have to be ready to drop, cover, and hold on again.
So there you have it. You know what happened, and now you know the right safety plan. The only question I have left for you is, are you ready to actually use it? Knowing what to do is that crucial first step, but having your safety kit packed and ready to go, well, that's what's going to get you through the aftermath. So, what's in your kit?